In this video, we're going to be taking our familiar states of matter and relating them to the heat that is involved when they change. First off, I hope we remember what our three states of matter are because we have talked about those a lot this year in general, especially last semester in chemistry. So our states of matter are solid, liquid, and gas. Remember, they are a physical trait of the substance. It's not a chemical trait, it's a physical trait. And we've also talked this chapter about how gas has the most thermal energy because it's moving around the most, whereas solid has the least because it's moving around the least. It's pretty packed and tight. So liquid is right in between there. So just keep that in mind with our states of matter. When we change states, we have some kind of heat either given to the reaction or put off from the reaction. So remember, it is a physical change. You're not changing what substance you have, but you are going to get some heat that's either given off or taken in. So you're going to either put in energy or take it out. So you can see on the graph, we have parts here like the melting point, we have the boiling point, and you can see in between it's telling you what kind of substance there is. So anytime on these graphs, and we're going to look more at these in class together, when the graph is diagonal, it is in a constant state. And then once it hits these points, that's when it is changing. So we have these boiling points. So this is when the liquid hits the point where it's going to change into a gas because it is it's got enough heat in it, it's got enough temperature and heat relation that now it's going from liquid to gas. This is the process of going from liquid to gas, and now it's a vapor. If you go the opposite way, this would be right here actually starting to go from gas to liquid, so this would be your condensation point. And then here is we're changing from solid to liquid, so it's our melting point down on the bottom left like I had already circled. And then if you go the opposite way, you'd actually have your freezing point because that's where we're going from liquid to solid. So it's just showing changes of state and what heat needs to be contributed, and also at what temperature this actually happens. So it's going to be different for each substance. While change of state, is not a chemical change, there is heat involved also in chemical changes. So when our bonds are broken, remember bonds have to be broken for a chemical change to occur, the heat is going to, bonds have to be broken and some have to be formed. But the heat's going to be given off because when you break that, it's giving off a ton of energy that was being held inside of that bond. So the heat's given off because the energy is given off. So that's what we call exothermic. We've talked about that last semester. When bonds are formed, now it's bringing energy into the reaction because it needs to take in that energy to be held between the bonds. So it's taking it inside, so now you have endothermic. So those are a couple things we did talk about last semester that hopefully that rings a bell a little bit, but we can relate that to heat.